If f of x equals 2e to the power of 3x divided by cos of 2x, evaluate the derivative when x equals 0. So we can recognize that we have a function divided by another function, which means that we have to use the quotient rule for differentiation, which is on the formula sheet, and it's the hardest, or it's the most complicated rule that we have for differentiation. But we do have a process that allows us to make this rule relatively easy to use. So just like the product rule for differentiation, we're going to start by letting u equal the top line of the fraction, which is 2e to the power of 3x, and v is then the denominator, which is cos of 2x for this question. And it's really important for the way that this rule is written that u has to be the top of the fraction and v has to be the bottom of the fraction. We can't swap those, so you have to make sure that that setup is correct as you're going through these questions. Next, we also need du dx and dv dx. So du dx is the derivative of 2e to the power of 3x, so it's going to equal, and we take the 3, the coefficient of x, and multiply it out the front, so it becomes 6e to the power of 3x. And then dv dx, if you look on your formula sheet, you'd find that when we differentiate cos, we actually get negative sine, and it's still of 2x. So now our rule for differentiating a function u divided by v is equal to, and now the nifty little way of remembering or being able to execute the quotient rule quickly is that we simply square the bottom line and then write its rule straight away on the top line of the fraction, and v multiplies du dx, and then we'd subtract away the opposite, so we'd have u times dv dx. So now the derivative that we're asked to calculate, f dash of x, is equal to, and we start off by squaring the bottom line straight away. So we're going to have cos of 2x all squared on the bottom line, and then we write its rule, cos of 2x, straight away on the top line. And it then multiplies du dx, which is 6e to the power of 3x, and then we subtract away from that the function u, which is 2e to the power of 3x, multiplied by dv dx, which is negative sine of 2x. So that's a rule for our derivative. And now we weren't asked for the derivative, we were asked for the derivative when x is 0. So that means we now need to take our derivative expression, and wherever there's x, we need to replace it with 0. So for our first term, we're going to have cos of 2 times 0, which is simply 0, multiplied by 6e to the power of 3 times 0, but 3 times 0 is simply 0. And then we're going to subtract away from that 2e to the power of 3 times 0, which is simply 0, times negative sine of 2 times 0, which is 0. And then all of that's divided by cos of 2 times 0, which is 0, squared. And now remembering our exact values, cos of 0 is equal to 1. So this will be 1 times 6 times e to the power of 0, and anything to the power of 0 is 1. And then anything to the power of 0 is 1 applies again there, and sine of 0 is equal to 0. And again, cos of 0 we just discussed before is equal to 1. So therefore, the derivative f dashed evaluated at 0 is simply going to equal, and on the top line we've got 1 times 6 times 1 for the first term, so that gives 6, and then we subtract away 2 times 1 times 0, which will just give 0, and then the bottom line just has 1 squared, which is simply 1. So therefore, f dashed of 0, which is what we were asked for in the question, is simply equal to 6 divided by 1, which is equal to 6, and that is the final answer for this question.